So let's now talk about how we can solve simultaneous equation using what we call Cramer's law. So how can I use Cramer's law to find the value of x and y to solve this system? So the most important thing is that we just need to know three steps. The first step is to find the determinant of the first matrix. So we are going to call this as matrix A. Okay. So now this is a matrix on its own. Now we are going to get the coefficient. So the coefficient of 2x is 2. The coefficient of 3x is 3. The coefficient of y in this case is 1. The coefficient of negative 2y here is negative 2. So this is matrix A. So if this is matrix A, the first thing what we're supposed to do is we need to find the determinant. So the determinant is represented by, you can say det or the modulus of A. I'm going to use the modulus of A. So the modulus of A, we want to find the determinant, that is going to be 2 times negative 2 minus 1 times 3. So this becomes negative 4 minus 3, that is now negative 7, meaning that the determinant of matrix A is negative 7. So I'll say A in the modulus, that gives me what? Negative 7. I leave it there. Now, the next thing is I need to find the determinant of x. Okay? What do I mean? The same A, but we are going to call it AX. So I'm going to say AX is going to be equal to, now what is going to be matrix AX? It's the opposite. Remember, if we go back to matrix A, this is x, this is y. So what we're going to do is we are going to replace x. When we want to find AX, we are going to replace x, the column of x, with what? With the coefficient that we have this side, which is 5 and 4. So then I'm going to say, I'm going to put 5, I'm going to put 4, then y is going to remain the way it is, like that. So there we go, we have got AX is, now I'm trying to find now the determinant of AX. So in the modulus, like we said, that is going to be 5 times negative 2 minus 1 times 4. Remember, it's minor diagonal minus major diagonal. So this becomes negative 10 minus 4, that is negative 14. Meaning that the determinant of AX is actually negative what? Negative 14. Now, the next thing is I need to find also AY. How can I find AY? I'm going to do the same. So I'll say AY will be equal to matrix AY is going to be, I need now to do the opposite. I'll leave this the way it is, 2, 3. Then I need to replace y with the coefficient, with these constant, the constant numbers which we have, which is 5 and 4. So I'll put now 5 and 4. Then let's now find the determinant. So it will be AY in the modulus, that becomes 2 times 4 minus 3 times 5, like that. So this is 2 times 4 is 8 minus, this is 14, 15 guys. So that is 15. So 8 minus 15 is negative 7, meaning that the determinant of AY is negative 7. Now, after finding now these two, I can go ahead and now find the value of x. To find the value of x, okay? To find the value of x, what I'm supposed to do is, I'm supposed to get AX, the determinant of AX divided by the determinant of M. So therefore, x will be equal to AX is negative 14, A is negative 7. So the value of x is 2. Okay? Now let's find y. To find y, we'll say the determinant of AY divided by the determinant of A. Just like that. Now because I don't have enough space this side, I'm going to get rid of this and go back to this. Y will be equal to, what is AY? AY is negative 7. What is A? The determinant of A is also 7, negative 7. Therefore the value of y is 1. Okay, so that's how I can use Cramer's law to solve the simultaneous equation. So this is what happens. Now look at this. How can you solve? If I give you this, I'll need the answer in the comment section. I want you to find the value of x and y using Cramer's law. So we have got x plus 3y, okay, that should be equal to 5. Then we also have 2x plus 2y, that should be equal to 6. Now you guys go ahead and find the values of x and y using Cramer's law. Just follow the same procedure that I've given you, and give me the answers in the comment section. I'll be able to check them out. Okay, so this is basically the method that you're supposed to use whenever you are dealing with what? Cramer's law.